Hello, and in this video we'll be looking at simultaneous equations on graphs, particularly how b squared minus 4ac may be useful. As you can see in this example here, we have a circle with a straight line. It's an example from the previous video, and we can see that they intersect in two places at 5 minus 1 and 1 minus 5, which are the solutions to the two equations. As it says, it is of course possible for a pair of simultaneous equations where one is linear and one is quadratic to have two real solutions, as shown on the left, where we have a circle being intersected by a line, one real solution where we have in the middle a circle met by a tangent, or no real solutions where on the right we have a circle and a line which does not intersect the circle at all. The quadratic equation produced when the simultaneous equations are combined will have two real solutions when b squared minus 4ac is positive, one real solution when b squared minus 4ac is 0, and no real solutions when b squared minus 4ac is negative. So I have invented this lovely curve, x squared plus xy equals y squared plus 5, to illustrate the idea. And depending on the equation of the straight line that we wish to solve simultaneously, it may have 2, 1, or no real roots. So when our linear equation is y equals x minus 1, as you can see from the graph, it intersects in two places. There are two real roots. And as you can see from the solution, we get a quadratic equation of x squared plus x minus 6 equals 0 when we solve simultaneously, for which b squared minus 4ac is 25, which is of course positive. In this second example, where the straight line is x plus y equals negative 2, substituting that in and rearranging, we get that 0 equals x squared plus 6x plus 9, which you may recognize as x plus 3 all squared, and b squared minus 4ac is equal to 0, hence there is one real root, and again we get a tangent to the curve. And then finally, I've used y equals 2x minus 1. As you can see on the graph, they do not meet, and if we were to extend the graph outwards, the gradients are such that they are never going to intersect. The quadratic equation we get is 0 equals x squared minus 3x plus 6, from which b squared minus 4ac is negative 15, which is of course negative, hence no real roots. For our last three slides, I'm going to give you some more problems to solve. On this slide, we have 4 more pairs of simultaneous equations to try. Here are 5 questions from the mixed exercise in the textbook. And here on the final slide is a question from the review exercise. Answers will be available separately. Thank you for listening.